All right, so we have chapter 1, the very beginning of the book, the real number system, and we're going to start with lesson 1.1, which is on page 7, and it's called Representing Rational Numbers on the Number Line. Okay, so what we're going to do is learn all about these kinds of numbers and where they live on the number line. The first section that we're going to cover, okay, in that lesson 1.1 is finding the absolute values of positive fractions. Okay, so just recall of positive and negative. We're going to do both positive and negative fractions. So just recall, what is a fraction? Remember we talked about types of numbers. Everybody got it? How do you know something is a fraction? What does it look like?
Has a numerator and denominator.
Numerator and denominator. Where do most fractions live if it's a proper fraction? If the numerator's bigger than the denominator, where does that fraction live between what two numbers on a number line? All proper fractions live between 0 and 1. Yes. Okay? So on a number line, if we have a regular fraction, it's going to be a proper fraction. It's going to be between 0 and 1. The book calls those spaces gaps. Okay? So here's a regular number line with both the negative integers and the positive integers. In between each of those integers is an infinite number of smaller, not smaller, but an infinite number of numbers. And each of those has a place. It lives somewhere on the number line. We're going to start being able to pinpoint exactly where they live on the number line. Okay? On the negative side and on the positive side. So all fractions fill the gaps. For example, 1/4 is a number that lives in one of these gaps. Who can tell me what gap it lives in again? What gap does it live in? Josh.
Between 0 and 1.
It lives right in between here. And then how could I figure out exactly where it lives? That's what we're going to start investigating. I'm sure a lot of you already have some ideas about that. Same as 2/5. 2/5 is a proper fraction, so you know it lives where? We've answered this 3 times now, so more of you should know. Read. Between 0 and 1. Excellent job. The fraction -3/4, though, where do you think that lives? Amaya?
Between 0 and -1.
Good. That, oh. It lives right there, and I even have it done for you.
I see that.
And, so between 0 and -1. Tyler?
Should we be copying down all of
This is kind of a discussion. It's all in that reading, so I don't think you need to copy this part down.
Okay.
Okay? And then -1 and 2/7. Be careful though, because this is not a proper fraction. What would we call this type of fraction? Nope, that's Matt. You are, help me?
Me?
Yeah, in the far, yeah.
Christian.
Christian, what do you call that type of fraction?
Improper fraction.
It's not an improper fraction. Improper is when the numerator is bigger than the denominator. Eric with 2 eyes.
Is it a mixed number?
It's called a mixed number, okay? So be careful. It doesn't necessarily live in the same space as those proper fractions. Where do you think this one lives? Ike.
Between 1 and 2.
Between what?
Oh, -1 and -2.
Between -1 and -2, okay? So this little red dot represents the -3/4, and this one represents -1 and 2/7. Is that starting to make sense? Right? When they're positive, they're relatively easy. On the negative side, you got to be a little bit more careful. Slow down a little bit and give it that extra second thought so you don't make a silly mistake. Because I think you're going to do it easily, but chances are if you do it too quickly, you're going to wind up making mistakes. The last thing I want to add is we reviewed absolute values, so you know about that, right? Where would this fraction live on a number line? Where would that fraction live on a number line?
Between 0 and -1.
Remember, absolute value of a number, is it ever going to be a negative value?
No.
So it's actually living between 0 and 1. Okay? Everybody see that?
Yes.
The absolute value of a negative number lives between that number on the positive side. And then, what other fraction would live exactly at that same point? Name me another fraction that lives exactly there. Chase? Yeah, 1/2 lives there, as well as the absolute value of 1/2 lives there. It's the same value with different names. Okay, so we treat them a little bit differently. Any questions on that? Okay, there's some practice for us on page 9. In the middle of the page, questions numbers 1 and 2. Okay, so read those. We're going to work on them together. Find the absolute values of 3 2/7 and negative 18/5. What is the absolute value of 3 2/7? Top.
A negative 3 and 7.
Is it negative 3?
No.
Oh, you're saying the answer is negative. Remember, this asks you, when we're doing absolute value, how far is that from 0?
3 and 2/7.
So that's your answer. It's not a negative. Absolute value will never be a negative because it's a distance. Negative distances don't make sense. Yes? Next one is negative what? Negative 18/5. So negative 18/5. And that equals what? Mr. Ziegler? 3 3/5. Everybody see how he did that? Yes? No? Okay. Do you want to tell Katie and the others your thought process? How did you go from this to that?
Well, 5 goes into 18 3 times, since this equals 15, and there's 3 left over, so it'd be 3/5, and you make it 5 from there.
Remember that? Do you remember doing that?
Yeah.
Okay, try this one for me real quickly. 11/5.
2 and 1/5.
Excellent. Okay. Questions on that? Okay. The next, number 2 says, graph these numbers on a number line and indicate their distance from 0. Graph them on a number line and indicate how far are they from 0. So let's do this one first. If I want to put that on a number line, 3 2/7, or the absolute value of 3 2/7, what numbers should I include in my number line? Like,
3
well,
And-
3 is,
and 4.
all I really need on my number line is 3 and 4. Notice I'm making it really big, the
4.
distance the distance between there is really big because I want to place this accurately. I want to know exactly where it lives in between those two numbers. Okay? So if this is 2/7, I could choose to divide this space up pretty logically to make my job easier. Anybody have an idea about what I might choose to divide this into? Madison?
7s.
If I chose to divide this up into 7s, all I would have to do is count over 2 of them, and that would be exactly where it lived. So as carefully as you can, you're going to divide this space up into 7s. Everybody do this now. Okay? So 1, 2, 5. And I wasn't real careful, but it's close enough.
That's 8.
Well, 7 lines gives me 8. Oh, 1, 2, 3, 4, 5, 6, 7.
Oh.
Okay? And then, like I said, we're already between the 3 and the 4, so we know it lives here. I divided it into sevenths, and I'm going to count over 2 of them and say that number lives, let's do pink, right there. Everybody happy with that? Mm-hmm. I like that. That's easy. The key is knowing what to divide it into. Anybody know where you find that key? How will I know that all the time? Lucas. No. I know. I forget again. Christian, yes.
We find out about the denominator.
Yeah, if you're trying to put a fraction on the line, use the denominator as the number of sections you want to divide it into, and then the numerator tells you how many to count over. So make a note of that. That's going to be real helpful when you're trying these on your own. Make a note of that, which means write it down. Denominator will tell you what to divide it into. Reed, can you write that down for me? The denominator indicates or shows how many divisions.
Just use the math vocabulary. Will help you.
And then what was the next number we were working on?
3 3/5.
3 3/5. So what 2 numbers do I want to use now on my, where does this live, and then what 2 numbers am I going to put on my number line? Or maybe I need more than 2 numbers, who knows? Yes? 3 and 4. So, was the last number between 3 and 4 as well?
Yes.
Well, let's put it on that number line. Why draw another number line?
Actually, no.
Well, you can draw a new one. Go ahead. Go ahead.
The reason why if we needed to draw like a new, we needed to draw a new line because the 2 denominators were different.
That's good.
And it could get us a little confused on where to put it.
I like Josh's thinking. Let's draw a new number line. You don't have to. If you want to, you can do it on the same number line. But if you agree with Josh that having 2 sets of divisions might be a little bit confusing, let's go with Josh's idea. Between 3 and 4. How many divisions do I want now?
5.
Everybody's hands up who thinks they know the answer. I'm not going to call on anybody yet. Excellent job. Now keep your hand up if you want to answer it. Who has not gone yet? Matt. Good. I want 5 divisions. So I need 4 evenly spaced lines. 1, 2, 3, 4. They're not even, but that's the best I can do. And now someone come up and indicate where you think this monster lives. Somebody who hasn't had a chance. Remember, effort and participation is important. Reed's been doing good today. Ah, Deja, is it? Is it Deja? Oh, I thought your hand was up, no?
I don't know.
Okay. Reed. Where does that monster live? Well, we have our 5 divisions, and we want 3 of them. Good job. Okay, everybody get it? Everybody like it? Is it fun?
Yes.
Yes!
It was fun.
Darn tootin', it's fun. All right, we're moving on to the next section called Express Integers and Fractions. Again, you don't need to copy this stuff down. All I'm doing is kind of reviewing what's in the book. Okay, so we'll read through it, I'll write some stuff, and then we'll do some more practice. A rational number is a number which can be written as m over n, where m and n are integers, and n is not equal to 0. Okay? So what that means is, this is an integer. We just reviewed integers very quickly in the beginning. Who remembers what an integer is? Anybody want to share what you think you remember? Okay, I'll remind you. All whole numbers and their opposites. So 1 and -1 are opposites. Those are integers. They're whole numbers. Is 0 an integer?
No. Yes.
It is. 0 is considered a whole number. In other words, it's not a decimal or a fraction. So all whole numbers and their opposites, just remember 0 doesn't have an opposite. So 0, 1, 2, 3, 4, 5, all those whole numbers, and -1, -2, -3, all those whole numbers. Yes?
Yeah, wait, when they mean opposite, you mean like
The
1?
-1.
Okay.
So 5 and its opposite, or 5 and -5. Okay? So this is an integer, and this is an integer. Something like this. 4 over 5. Are they both integers?
Yes.
Is this 0?
No.
Then that is a rational number. Okay? This proves if it's a rational number. Everybody got it? Excellent. Why can't n be equal to 0? Why can't n be equal to 0? Josh!
N can't be 0 because if every single number above 0 is greater than 0.
Well, the negative numbers too, they're not above 0.
But they're still greater because
No, they're less.
the opposite number is greater than
-1 is less than 0. So you have a good idea, but that's not why. Everybody else have an idea? Tyler?
It wouldn't be a fraction.
Yeah. In a sense, yes, I would agree with that. But there's like a mathematical rule we could identify, and then everybody'd be happy. Or at least I would be happy. All right, who has a calculator? Divide for me 5 divided by 0. Huh?
Divide by 0 error.
Ah.
Just messed up.
So the calculators don't know how to do it?
No.
Yeah.
Wait,
Did your
wait.
calculator work?
Wait, what do we have to do?
Just 5 divided by 0. Did your calculator work?
No.
Yours didn't work. Does anybody's work?
Yeah.
Mine does.
Okay, the reason it's giving you all these errors, sometimes it'll say syntax error, sometimes it says math error. That one actually said divide by 0 error. It doesn't exist. It's undefined or it's an error. You can't do it. That's why n can't be 0. Okay? And if you think about what that means, if you have 5 items and you want to divide them into 0 groups, I have 5 things that I want to divide into 0 groups. Exactly, that's why it doesn't exist. Okay? Now there's a good way, and what's 0 divided by 5, by the way?
0.
0. So there's a real quick way that I use to remember what I'm allowed to do and what I'm not allowed to do. Okay? If this is a number on top of 0, so this is n stands for any number. A number on top of 0, no. See, no, you can't do it. Okay? So no. What if their 0 was on top of a number?
On.
It's on. You can do it. Right? It's on. Come on, that's it.
Yeah.
All right. So no, you can't do it. A number on top of 0. Yes, it's on if 0 is on top of the number. Okay?
Okay.
Got it. That's why n can't be 0. Yes.
I forgot you wanted to show us like that thing for on
The square root key?
Yeah.
Did you find it?
Yeah, I found it, but I don't know what to do.
Okay, so you're going to hit it
Wait.
and then do like 16 or something. And then hit
I can't
equals.
find it.
Oh.
So the square root of 16 is 4.
Okay.
Yep. Excellent.
Wait a second.
Example number 2 at the top of page 10. Everybody there? Top of page 10? Write each number in m over n form where m and n are integers. So they start, do you see where we are? Okay. So we want to put these numbers so that they look like one number on top of another number. Okay? So when you have a whole number, all you do is put it on top of 1. Right? Because 23 divided by 1 equals 23. Is this a number? Come on, more participation than that.
Yes.
Is this a number?
Yes.
Is this a number?
Yes.
Is this 0?
No.
Is that a rational number?
Yes.
Okay. Part B, negative 45. When you have a negative, just give one of the two numbers the negative sign. So in this case, I'll try negative 45, and then on top of 1. Okay? So it's the same idea as the whole number, where you just put it on top of 1, but give one of the two numbers that negative sign, because this was a negative. Make sense?
Yeah.
So I could have done 45 on top of negative 1 as well. Both are correct. Part C asks us to do 11 and 7/9. Okay? Now, and again, what kind of fraction do we call that? Christian? Mixed number. Good job. But we want one number on top of another number. We don't want this whole number part. So what can I do to that? Hussey.
Make it an improper fraction.
Make it an improper fraction. Well said. How do I do that? Who remembers? Does Katie remember? It's like the opposite of what you remember from earlier, right? It's okay if you don't. Yeah, it's like, oh, I did that last year. Oh, Josh, you're going out of your seat. Tyler.
You do 9 times 11.
9 times 11 is 99.
Yeah, plus 7 is
106 over 9. And you keep the same denominator. Katie remembers now. Okay? So you do the denominator times the whole number plus the numerator.
Where's the 1?
We don't need a 1 in all of them. Right now, is this a number?
Yeah.
Is this a number?
Yes.
Is this 0?
No.
Is that a rational number?
Yes.
Excellent. You're going to try, please, the bottom of page 10, numbers 3 to 6. Numbers 3 to 6. On page 10. Use what we did as a guide. They're the same types of numbers. Whatever we did in the practice ones, just do the same thing. Vanetsky?
So we just change the numbers to what we just did?
Exactly what we just did. Should be very quick and easy. Absolutely.